One. So in this video we are going to see how we can get a minimum spanning tree from the following graph by using the Kruskal and the Prim's method. Now while we are using this method, we will take care of one thing, that the edge is selected in such a manner that it contains a minimum weight and add it to the M, that is the minimum spanning tree. And we need to take care of this thing also, that in the minimum spanning tree there should not be any cycle, that is there should not be any loop. So we have to take all the edges and make the minimum spanning tree, and it should not have any cycle. Now let us start by taking the first edge, that is we will start from the lowest edge weight, that is 1. It is from 1 to 2, that is the vertex 1 to 2 in the graph. So we will write here as, now we will take the first edge vertex here 1, that is, and from 1 to 2, and the weight is 1. Now in this we need next step is to find the next lowest weight. Next lowest weight here is 2, that is from 2 to 3. So we will join here from 2 to 3 and mark the weight as 2, as the next weight is 3. So next minimum weight edge is from 4 to 5 and 6 to 7. So we will mark it here as in the same place as it is in the original graph. 4 to 5, that is 3, and then 7 and 6, that is 3. Now for the next highest weight is 4. So 4 in this graph is from 1 to 4 and 2 to 5 and 4 to 7. So we will mark the weight from 1 to 4, that is 4. 4 to 7 we can also mark as 4, but we will not select the edge from 2 to 5, which is having the weight 4, because this will create a loop in this minimum spanning tree, and we don't need any kind of loop. Similarly for the next weight, that is the 5, after 4, that is this one is the smallest weight left. Now for the 5 we will not add this 5 edge, because if we are adding this 5 to 3 edge in the minimum spanning tree, this will also create a loop in this graph, in this tree. So, and again for the next weight, that is 6, from 2 to 4 and 3 to 6, this will also create a loop. So we are not going to add these edges, and as we have all the vertices in this tree which were in the graph, so this is our final minimum spanning tree which we obtained from the graph. Now while using the Prim's method to get the minimum spanning tree, we will do something different. And in this Kruskal method, what we did is we just marked the edge in the same place as it was in the original graph, but we will not do this in the minimum spanning tree obtained by Prim's method. Now for the Prim's algorithm, what we will do is, now we will see how we can get the minimum spanning tree from by the Prim's algorithm. At first we will take any vertex, let's say 1. From 1 to 2 we will mark the first edge, that is having the weight 1. Now from this we can see that the vertices connected to the vertex 1 is are the 2 and 4. So connected to 1 are 2 and 4. So we will see the minimum weight. The weight of 2 is equals to 1, and the weight of 4 vertex is 4. So the minimum weight is of 2. So we will connect the vertex 1 with the 2. Now for the next we will check that from the edge vertex 2, what are the next reachable vertices. So next reachable vertices are 3 and 5 and 4. So for the vertex 2 we will see that the weight of the vertex 3 and to the vertex 5 and to the vertex 4. So the vertex 3 weight is 2. Now for the next vertex, that is 5, the weight is 4, and for the next 4 is the weight is 6. So the minimum of these 3 is 2. So we will mark the edge from 2 to 3. Now we will move to the vertex 4, and then we will see that the lowest weight edge going from the 4. So from the 4 there are 3 roots, that is to the 2 that weights 6, and to the 5 that weights 3, and to the 7 that weights 4. So we will select the minimum out of these 3, and that is the 3. So that is the root to the 5. First we will go from 1 to 4, that is the weight 4. Then we will move from 4 to 5, that is having the weight 3. Now after this, what we'll see, the roots going from the vertex 5 are to the vertex 3 and to the vertex 6, that is weight 5 and 8. We can also see that the root to the vertex 6 or 7 are having some another path, and that weights less. So we will choose that path for the minimum spanning tree. That is, we will move to the vertex 4 and select the path that is 4 to 7. So we will move from 4 to 7, that weights 4, and then we will see that the edges going from 7 to 5 and 7 to 6, that weights 7 and 3 respectively. So we will select the minimum edge weight, that is 3, from 7 to 6. So this will be our final minimum spanning tree. So in this we can see that there is no loop at any place. So this will be the final tree, and also we have covered all the vertices that were in the graph. And if we add the weight of all these edges by using the Prim's method algorithm or the Kruskal's method, we can see that the weight of all the edges will be minimum. That gives us the minimum spanning tree. So this was all, and thank you so much.